All right. Welcome to part 2 for 5.6, factoring trinomials. Okay, so let's go ahead and continue here. So factoring 5.6, factoring trinomials. Part 2. Okay, so we are going to look at a little more challenging problems here. Okay, so we did 3 examples in the first video where the coefficient of x squared was 1. Okay, so now we're going to take a look at 3 examples where the coefficient of x squared is not 1. Okay, so let's take a look at this one. Example number 4. Factor completely. And let's do this one. 5x squared plus 7x plus 2. Okay, so again, we're trying to find the 2 binomials that we multiply to get this trinomial. Okay, so there's only one way to make 5x squared. That's 5x times 1x. Okay, so this one's not too bad. Whenever this is a prime number, whenever any of these are prime numbers on the ends, then, it makes it a little easier. Okay, so here we want a positive 2. So that tells me that we can't have a positive and a negative because then that'll make negative 2, right? So the signs have to be the same, either both positive or both negative. Looking over here, this tells me that they will both be positive. Okay, and there is only one way to make 2, 1 times 2. Okay, so let's suppose that we put the 1 here and the 2 here. Okay, so let's go ahead and check our middle term. We do the outside product, and we get positive 10x. And we do our inside product, that's positive 1x, and that gives us a total of positive 11x, which is more than what we want for our middle term. Okay, so we only have 1 and 2 to choose from, right? 1 and 2. So it didn't work. So you might be asking, okay, well, if that doesn't work, then what do we try next? Because there's nothing left on our list, right? Okay, so what you can do is try switching the 1 and 2, putting the 2 here and putting the 1 here. And the reason why we can try that is because these are different. Okay, when these are different, you can try switching their positions. Okay, so when these are different or when the signs are different. Okay. All right, so let's go ahead and try that again. So 5x times x will give us 5x squared. We already know that the signs will be positive, positive, and we're going to try the 2 here and the 1 here. Okay, so let's take a look. On the outside, that product, 5x times 1, is positive 5x. Positive 2 times x is positive 2x. And this gives us positive 7x, which is what we want for the middle term. So that is the correct answer. 5x plus 2 times x plus 1. Okay. All right. Let's take a look at another one. Okay. Suppose we have this one here, factor completely. Three p squared minus 4p minus 4. Okay, so a little more complicated because this is a prime number, but this one isn't. Okay, so we have more choices. All right, so only one way to make 3p squared. That's going to be 3p times 1p. We want a -4. So the only way to get -4 is if we have different signs, one positive and one negative. Okay, maybe they're in the wrong place. We don't know, but that's okay because we saw in the last video that, oh, if they're in the wrong place, then we'll end up with positive 4p, and all we have to do is change the signs, right? Easy fix. So just place them somewhere and we'll worry about whether they're in the right place at the end. Okay, so to get -4, we can try 1 and 4, 2 and 2, and we can try switching their positions since 3p and p are different. Whenever these are different or the signs are different, then you can try 1 and 4 or 4 and 1. Okay. All right. So let's see. Suppose that, which one do you think it is? Okay. I heard some of you guys say 2. I can hear you all the way over here in my house. Okay. All right. So let's go ahead and check the middle term. So here, 3p times -2 is -6p. 2 times p is positive 2p. And this here will give us -4p. Now, just because you want -4p, make sure you really do get it. Oftentimes students really want that -4p, so they'll like do this calculation really quickly, thinking it's going to be -4p, but it turns out to be positive 4p. So just really make sure that you're doing the calculations correctly. All right, so this is the correct answer. So 3p plus 2 times p minus 2. Okay, and let's go ahead and take a look at example number 6. So let's take a look at this one. This one here, like I said, always check for common factors. I haven't really been checking it out loud. I kind of checked it mentally. Okay, so, but I'm going to say it out loud here because guess what? We're going to have common factors. All right, so let's take a look. -15x squared plus 25xy plus 60y squared. Okay, so clearly this here looks a lot more complicated. We have double-digit numbers. This is a negative number. We haven't had that yet. All of these problems here, they've all been like single-digit numbers, right? And it's kind of easy, prime numbers even. And this has always been positive. Positive 5x squared, positive 3p squared. Okay, we're going to go ahead and take a look and see if they have anything in common. And we notice that they do. They all have -5 in common. Okay, so since we've been working here with positive leading term here, we're going to go ahead and continue with that. So in order to make this positive, I'm going to go ahead and factor out the common factor, which is -5. And by doing that, this becomes positive, right? And then over here, this next term will become negative. And this third term over here will be negative. Okay, so this is much easier to factor than this trinomial. So that's why it's always nice to try to find a common factor and factor it out right from the very beginning instead of at the end. Okay. All right, so in your answer, your final answer, the -5 will still be there. So don't leave it behind. Okay, so -5 will be part of your final answer down here. All right, so let's go ahead and find the two binomials. This is nice. It's a prime number, so there's only one way to make 3x squared, 3x times 1x. Okay. And here we want negative. So the signs have to be different. Okay, so the signs have to be different. So again, I don't know where they go, but if we end up with positive 5xy, then I'll just change the signs. Not a big deal. Okay. All right, so 12. Lots of ways to make 12. 1 and 12, 2 and 6, 3 and 4. Okay. All right, so let's check 2 and 6. Okay. All right, so outside, I get negative 18. Oh, I forgot my y's. Okay. I get negative 18 xy. And then inside, I get positive 2xy. That gives me negative 16 xy. And that is not what I want. Okay. All right, so we could try, so that didn't work, right? We could try 3xx, positive, negative. We could try switching them, right? Because if these are different, then you can try switching them, putting the 6y here and the 2y here. But I know that doesn't work because look, I don't have to check this one, and I'll tell you why. It's kind of a little checking trick. I don't have to check this one because if I put a 6y here, then I see that this binomial has 3 in common, right? Well, if the binomial has 3 in common, then the original problem should have 3 in common, which it does not. So I know this is not a possibility. Okay, so I don't need to check that. All right, so we know 2 and 6, no matter which positions they're in, that one is not going to work. Okay. All right. So I think I hear you guys saying 1 and 12, 1 and 12. Okay, so let's try 1 and 12. All right, so outside, negative 24. Oh, I forgot my y's again. Negative 24xy. Inside. Oh, did I mess up on my signs? Oh, I sure did. Okay. See this here? Oh, no, no, no. We're good. We're good. We're good. Okay. All right, so here we get, ooh, that's big. 3 times negative 12. That's not even. Hold on a second. Which one am I doing? 1 and 12? Okay. 1 and 12. 3 times 12 is not 24. That's where I messed up. 3 times 12 is negative 36 xy. And then inside we get positive 1 xy. And that gives us negative 35 xy. And that's not what we want. Okay. Okay. Oh, you know what? Yeah, that doesn't work. Okay. All right, so that doesn't work. Again, same reason as trying to put the 12 here. If I put the 12 here and the 1 there instead, well, then the 3 and the 12 have 3 in common, but then the original problem should have 3 in common, right? Okay, so that doesn't work. So 1 and 12, no matter which position we have it in, will not work. Okay. All right. I'm going to bring the problem down here because now we're getting farther away from it. This is what we're trying to factor. Okay, we're trying to factor this. Bring down the 5, the negative 5. All right, so we know we have 3x and x. We know we need a positive and a negative. Okay, so the last thing to try is 3 and 4. We know not to put the 3 here because then they'll have 3 in common, but the original problem doesn't have 3 in common. So let's try putting the 4 here and putting the 3 here. Okay? All right, so we're trying to make negative 5xy for the middle. So let's check. Here we get negative 9xy. Ah, I forgot my y again. Don't forget your y's. Okay, negative 9xy. And then on the inside here, we get positive 4xy. And here I get negative 5xy. What do I want for the middle? Negative 5xy. So this is the correct form. Okay, so your final answer will have the negative 5 that you factored out from the very beginning, 3x plus 4y, and x minus 3y. Okay. All right. If you want to see more examples that are a little bit more challenging, which includes substitution, a little bit of a substitution problem, then watch the third video.